In this video, the kind of series we're going to discuss is called telescoping series. So for this series, we're going to have a simple form for computing the series. So typically the method for telescoping series is to use partial fraction decomposition. Okay, so the way to recognize a telescoping series is typically it will be one where almost all the successive terms in the series will collapse or they'll cancel out. So we'll see in this example exactly what I mean by collapsing. So for this series, what we're going to do is we're going to write out the first few terms until we see the pattern of cancellation. Okay, so let's write out the terms of the series. So for the k equals 1 term, so you get 1/3 minus 1/4. And the k equals 2 term, 1/4 minus 1/5. And then the k equals 3 term, you get 1/5 minus 1/6. And then the k equals 4 term, you get 1/6 minus 1/7. And so on. So you'll see the k equals 5 term, you start off with 1/7, and then this pattern will continue. Okay, so now that we have the first few terms, you can see some of these terms cancel out. So the minus 1/4 will cancel out with the plus 1/4. The minus 1/5 will cancel with the plus 1/5. Minus 1/6 plus 1/6 minus 1/7 plus 1/7. And this pattern will continue indefinitely in the series. And so you see that all the terms cancel out except the first term. And so this series converges and it's equal to 1/3. And so this is typically going to be the pattern of the telescoping series. So again, you write out the first few terms and then see which of them cancels out. So let's take a look at another example. Okay, so the next example we'll look at is this series here. So you see that the form of the series is slightly different. So it's written as a single fraction instead of the sum or difference of two fractions. So we want to write it in the previous form. So we want to rewrite it in the form. So we want to separate the fractions a over 3k plus 1 plus b over 3k plus 4 using partial fraction decomposition. Okay, so let's see how we do it using partial fractions. Right, so what we do is recombine it and set it equal to the original expression. Okay, so we recombine these two fractions. So you'll get a times 3k plus 4 plus b times 3k plus 1 all over 3k plus 1 times 3k plus 4. This has to equal to this. So the numerators have to be equal to each other. So now we just solve this equation. Right, so collecting like terms, you get 3a plus 3b times k plus 4b. So the terms without k is 4a plus b, and this has, so 1 is the same thing as 0 times k plus 1. Right, so the k should be the same, and then the constant term should be the same. So you get the system of equations: 3a plus 3b is equal to 0, and 4a plus b is equal to 1. And now we solve for a and b. So the first equation tells you that a is equal to minus b, and the second equation will now say that minus 4b plus b is equal to 1. So b is equal to minus 1/3, and then so that means that a is equal to 1/3. Okay, so now that we have a and b, we go back and rewrite this expression here. So this is the sum, k equals 1 to infinity. So a is equal to 1/3. So by plugging 1/3 into this, you get 1 over 9k plus 3. And then b is minus 1/3, so this will be minus 1 over 9k plus 12. Okay, so now let's take this and write out the terms. So for k equals 1, you get 1/12 minus 1 over 21. When k equals 2, you get 1 over 21 minus 1 over 30. And then when k equals 3, you get 1 over 30 minus 1 over 39. And let's do the next one. So k equals 4. The first part is going to be 1 over 39, and then so on. This pattern will continue. And so we again see that the minus 1 over 21 and this term cancels out this term cancels, this term, and this term cancels. So again, only the first term is left. So only this term. So again, the series converges to 1 over 12. And so this is what a telescoping series is. So not all of the terms will always cancel like this, but you want to cancel as many of the terms as possible, and then just pick out the remaining ones, and that'll tell you how to calculate the series.